In this video, we're going to look at the gradient graphs of quartic functions. First of all, we'll look at a positive quartic function. So we've got 2x to the 4 minus 5x cubed minus x squared plus 4x plus 1. So what we'll expect to happen before I run it is here we're going to have a negative gradient. What's going to happen to this negative gradient is it's going to be at its steepest at this point here, further to the left. As you come to left to right, the gradient's going to ease off. It's going to become less and less steep. So that's going to tend towards 0. So then we're going to have a steep negative gradient coming up to a point of 0 gradient here. In this section here, we're going to see a positive gradient, which means that we'll see the gradient graph above the axis. Between the two turning points is going to be the steepest positive gradient here. So we're going to see a turning point. And then the gradient's going to ease off towards 0 again at this turning point. We're then going to see that again for a negative gradient here. So the negative gradient, remember, is going to be below the axis. The steepest negative gradient, the highest value of the rate of change, is going to be halfway between. Then we're going to have a point of 0 gradient here, and then a positive gradient. So if I just run the animation, we'll see what the gradient graph actually looks like. So we got a gradient of minus 50 here, you see, so we're not going to see that on our graph until we're coming up here, and then we get this gradient coming up at minus 6, minus 5, then heading towards 0. Therefore, we get a positive gradient now. So the highest rate of change, remember, will be halfway between the two turning points, which we see there. At 0.5, we have a vertex, which means that's why it's passing through the axis at that point. Now we have a negative gradient, and the highest rate of change again will be halfway between the two turning points. And then at this vertex, we're going to have a gradient of 0, which is represented there. So therefore, you see that when we differentiate a positive quartic function, we're going to get a positive cubic function, as you can see from the gradient function. Looking at a negative quartic function here, picked one here then, we'll just look at the gradient again. So I just run the animation. So again, we're starting off a gradient of 15 here, at this point here, which we can't see at the moment, but as I run it here, we'll see the gradient coming here. So at the vertex, we're going to have a point 0 gradient. So it's going to pass the axis here, because remember, we're plotting the x value against the gradient. Between the two turning points, again, we're going to have the highest rate of change here. So that's going to be why you've got a turning point there. And then again, between these two turning points, you're then going to have the highest rate of change is going to be halfway between. And then what's going to happen is, see, the gradient is decreasing as you get towards the next vertex, the next turning point, and it passes through the axis at that point. So therefore, you see here that if you derive a negative quartic, you're going to get a negative cubic.